Let's start. Today we are going to be leaving the text-based interface that we're doing now with print, and we are going to look at how to implement user interfaces using something called PyQt, and how to think about user interfaces in Python as well. So one thing is we think about user interfaces that we need to hide complexity. And if you look at today's computing world, you have Windows, you have Linux, you have Mac, you have iOS, and all of these platforms have their own ways of implementing user interfaces, unless you are talking about web interfaces, because that's different. So user interfaces I'm talking about now is like applications like Word, AutoCAD that runs on your computer. So if you look at different platforms and how they do it, you have your application that talks to, for example, on Linux, there is a user interface library called X11. And that talks to the operating system itself. So there is a layer in between that presents the windows on the screen on a Linux machine. On a Windows machine, we have something called Win32 or WinRT, which is the user interface library toolkit on top of Windows. And if you are on a Mac, you have something called UIKit or NSKit, which is the library that you use for implementing user interface on a Mac and on an iPhone. And underneath, you have Mac OS or iOS underneath here. So if you want to implement a single application here, you have a problem. You have to implement one application for each library, which is really not what we want. So how do we solve that? So instead, if we have one application, we put a layer in between. So in Python, that is called PyQt, and it's something called a binding. That means that it's a Python thin layer on top of a library that's implemented in C++. So underneath here, we have something called Qt, which is a user interface library which encompasses all platforms. So Qt, if you write against Qt, you can deploy your application on Linux, on Windows, on Mac, and even on an iPhone. So you have this layer in between, and the binding is the layer between Python and the Qt library that we implemented in C++. If you look at NumPy, for example, which you have already used, that's implemented in C. And NumPy is a Python binding to the underlying math libraries. So Qt, it's a platform-independent user interface library, and it abstracts all the interface concept into a single library. So that you don't need to call any native functions on any platform. You can call single function in Qt, and your code will look the same regardless of you're running it on a Windows or Mac or a Linux operating system. Another nice thing with Qt is it also adapts to the current platform. So if you're running an application on a Mac, it looks like a Mac application. If you run it on a Windows, it looks like a Windows and so on. You can also style your user interfaces, so you can make them look like really cool things. You can completely style it in the way you want it to look if you want to kind of diverge from the platform look. Another thing that is something we will go into detail later here is that events is something that, for example, if you click a mouse, you press a key, that's an event. And that is handled using something called signals and slots. So a mouse press will send a signal, and you connect that to a slot, which is a function. So to be able to handle events, you have this mechanism called signals and slots, and that's built into Qt. Qt in Python. So Qt is a C++ library, so we can't call that directly. We need something extra to call that library. And that is what I told before is a binding. And it's a binary module connecting Python with Qt. And unfortunately, in Qt's case, there is actually a lot of different Qt bindings. So there are something called PyQt 5 or even PyQt 6. We have Qt for Python, also called PySide, and Python Qt. And in this course, we are going to use PyQt or PyQt 5. But you see here, there is a problem here that we need to handle somehow. And I don't know why the Python world ended up in 3 different bindings, but that's the world of open source sometimes. So first, before we go into programming user interface, we need to think a little bit how user interface applications work. And we are going to look at something called event-based programming. And event-based programming is always centered around an event loop. So you can imagine a program, Word or anything, it sits on your screen, and what it does, if you don't do anything, it just sits and waits for something to happen. And that's something that is going to happen is an event. So you click the mouse on a menu, that's an event, and then this loop will check for, oh, the mouse was pressed. So it waits for messages from the operating system, keyboard, mouse, system messages, and in the case of an iPad, you also look at for touch, for example. So all that is checked in this loop. And then that event loop dispatches messages to the code that should actually handle the event. So what should happen when you click the button? What should happen if you move the mouse with the button down, for example? And the loop only terminates when the last window has been closed. So the program is continuously sitting in a loop and waiting for things to happen. And so it's a bit different from the code that you have been running now that starts at one point and ends at another point. So pseudocode in Python for an event loop looks like this. You have a flag called running equals to true. And then you have while running, check if there is an event. And if the event type is button click, handle button click. So then we kind of pass along what should be done to another function that actually performs the method. And then you have a continuous long list of different event checks that you do. And finally, you have if event app quit, running equals to false. And when running is false, the while loop terminates and exits. So on a high level, this is what your Qt application will look like. It will kind of go around in a loop forever until something happens or you terminate the application. So, as I said, many bindings for Python. So which should I choose? And is there a way of avoiding this multitude? And there is something called QtPy, which is kind of PyQt backwards. And that module can be used instead of specifying PyQt directly. So this module actually checks what Python bindings for Qt is installed and replaces those with the current one. So you don't have to actually think about which Qt binding are you using. You can just use QtPy instead. So that's why the reason if you see examples here where it says QtPy instead of PyQt is because of this special module. So if we look at the main program of Qt main program, we have here we have qtpy.qt widgets. So the main user interface components in Qt is located in this Qt widgets module, and we import all the classes in that module. Then we have a main program, and the first thing we have to do is to create something called an application object. That is the object responsible for kind of holding all your windows and making sure that you have an event loop. And you create that like this. The reason for this sys.argv here is that you can, when you start this application, you give it some extra parameters from the command line. But you still need, even if you don't do that, you need to specify this here. That's why we also have the sys import here. Next, so the application object in itself doesn't kind of show anything. It just starts up and creates. But to be able to show something, we need to create a widget or a window. And the base object in Qt is the Q widget. That is the basic control that base object that all other objects derive from. If you instantiate that, create that object and show it, it will show you a window. So if you don't add something to it, it will display a window. So first we create a widget and then we show it. So you always have to tell it to show itself on the screen. And then finally, we go into the application loop, and it's called app.exec_. And the reason for the underscore is that exec was already taken in Python, so they put an underscore here to differentiate it. And then it returns if something goes wrong, it also returns an return code, which is passed to the sysexit function here. You actually don't have to do that. You can just do appexec if you want as well. And I'm going to show you this example here, ex1. So here is the code. So we have the main application object, and if we run this code now, you can see here that it brings up a window. And you can also see that it doesn't exit here. It sits here on the terminal and waits for the window to close. And it still knows how to, you can resize the window, you can move it around. So all that functionality is built into the widget and the application object itself. And you can see here also, if I do print, so run this code here, you can see the print statement is not executed, but if I close this window, where did it go? Because the application closed with sysexit here. But if I do like this instead here, just for a simple example here. Now you see, it goes into this loop until I close the last window. So the sysexit function that exits a Python application directly. Yeah, so if you say other programs in Python that has PyQt, it's perfectly fine. But you can in this course we will use qtpy dot and Qt widgets import. I will show you. So if you create a widget with that is not owned by another object, it will create a window automatically. And here you can see some of the object orientation that is used to implement the functionality. So on top here we have the Q widget, which can be compared to a window on your platform. You can derive your own custom window from this, which we will do in this course. And then you add other objects here to this window. So you have a line edit for entering text, a label for showing text. You can have a group here that contains other controls. So in this way, you can use this. The notion of object orientation comes very good in hand here to implement the user interface application. And all of these objects here, the Q group, the Q line, are all derived from this Q widget base widget. So a lot of the functionality of the Q widget is kind of implemented in these as well, so you can reuse that. So when you create a new application, you should derive your own window from Q widgets. So you can specify the functionality of your own window for your own design here. So usually what I do is I do class my window and I derive that from QWidget. I create my own constructor here. I call the derived constructor here. So this calls the constructor of the widget. And then I usually have a special routine called init GUI, which I call here to define my user interface. So in this case, I do set geometry, which sets the size of the window, in this case, size and position. It positions the window at 300 by 300 on the screen and sets it to 600 by 600 in size. I also set the window title, so it doesn't show python.exe, which is kind of not nice. And I do show here as well. So this looks like this. If I run it, this was x2. So here I have my window class here, and then I use it by creating like this. So now I have my own window that I create. So window equals to my window. And that will automatically show itself here because I have the show method called in the init GUI. So running this, now you see here, the only difference from before that it placed the window at 300 by 300, resized it to 600 by 600, and you can see the title also changed here. And here's the main program again. So now I have a window. It's kind of not very useful just to have a window. You have to kind of have some user interface controls on that window as well to be able to use it. So in the init GUI method, I create a button here. And a button, the normal standard button in Qt is Q push button. The first argument here is the text that is going to be on the button. And then the second argument is the owner of the button. And then when I pass self here, I tell Qt that this button belongs to the my window class. So my window takes responsibility of this push button. It is placed on that window. I can set a tooltip, and a tooltip is when you hover the mouse over a button, it brings up a small help text, and you can see here, I'm a button, please press me. I can do resize and move. These methods here, the resize and move, comes from the Q widget, so that is the base functionality of all widgets. So resize sets the size of the button, move moves it to the position here. So now you can see here that I have a small button here in my window. And if you see here, if I hover over it, it will display the hint text. And you can see all these things that when you move over here, it's automatically implemented in the application. You don't have to shade the button to illustrate that you're moving the mouse over. It's automatically, it knows how to do that. So you see, there is no, when I press the button, nothing happened. There is no code connected to the press of the button. And to be able to handle that, all the Qt controls have a number of events and signals that you can connect methods to. And for example, my button has a signal called clicked. There is a signal called pressed, and that is when the button is held down. So a click is when you push down or release, that is a click. When it's pressed, it's when you're holding the button down. So it's two different events. And for example, the list box here has a current row change. So when you have a list box and select different rows, that method would be called. And these can be assigned, and that is done using the connect method. So to be able to connect the signal to your own code, you use the connect method. So you can liken it to having cables that you want to connect in the socket. So you pull out the cable and connect it to the socket. And then you do that with the connect method. So here I have my button clicked connect, and then I give it a method that should be called when the event clicked is received. So if we look at EX4 here, you can see here I have the same code here. I create the button just like before, but the difference is that I do self button clicked, which is the signal, and I connect that signal to self unbutton clicked. And that is a method in my class here. So you can see here I have unbutton clicked here, and it prints hello if that event when that event is called. So let's see what happens if I run this. I have the press me here, and if I press, you can see here below that it says hello. So now we have created a link between the event and your own methods. So this is how the basic building blocks of a user interface application is that you connect events to methods. And it sounds easy, but it can be quite complicated because it's not linear. So the user can click anything in any order. So you need to have to think about should the user be able to click a button or not? So sometimes you need to disable controls because they are not available at a certain time. For example, if you have a computational code, you pressed run, and at some point, certain user interface features can't be done until the computation is completed. So for example, if you want to look at the visualization, that can't be done unless you have a computation. So you need to think that events can happen in any order. If you want to know about which events and signals, you can go to the Qt reference library. So here you can see Qt widgets module. There are all the event signal documented. So let's see if we can. So here you can see all the classes we have. So if we go into the push button, you can see there is a lot of user interface controls in push button here. You can see the public functions, and you can see the slots. So slots are things that you can connect signals to, but it's not something we're going to use here. But here you can see here signals. Okay, we think if we're going to go up a bit. Here you have the signal: clicked, pressed, released, toggle. Because push button is derived from the abstract button class, so it inherits the functionality of an abstract button. So that's why it doesn't show here. So most of these functions are for C++, but Python methods have the same argument, the same order. So you can find a lot of information here. But you will also get a lot of all the source code you see here. You will get from me. So you can try and experiment with all that code yourself and see how it works. So because I think it's important, but it can be quite complex to implement these applications. So it's good to have some examples to try out. Then there are some common properties of the controls. So you can set, for example, if the control should be visible or not. And that can be important if you want to hide user interface controls that is not available. You can set visible, true and false. You can check if its control is visible by using the .isVisible method. You can see if it's enabled. So you can actually disable a control. It's visible, but you can't press it. Then it's disable, and you can enable that using set enabled, true or false. Check if it's enabled using is enabled. Focus is a way of setting focus on a control that can be pressed by a key. So for example, if you have a lot of line-edit controls where you can enter text, the cursor can only be in one of these controls at the same time. So with set focus, you can tell which one it should be at when it starts up. Another important, most of the controls that have text connected to them, the text is set using the set text method. And you can retrieve the text using .text. So the line edit control, for example, has a method called set text, and you can get the text that the user entered by using the .text method. So we will look at how this is implemented here. So here we have 3 buttons. I have connected the first button to button 1 clicked and the second to button 2 clicked. And in the first method here, we check if button 2 is visible, then we set visible false on that button. And if it's not visible, it's set visible to true. And then we have button 3 here. If it's enable, then it sets button 3 to enable equals to false. And then we have set enable equals to true otherwise. So how does that work? 3 buttons. You can see here they're all available to press now. If I press the first one here, you can see the second button disappear. It's still there, still an object, but it's invisible. If I press it again, it appears again. If I press this button here, you can see here, you can't press it anymore. It's disabled. And sometimes it's good to give a hint to the user, this control is not available yet. For example, if you have buttons for showing the visualization of your results, it could be grayed out or disabled until you have run the calculation. Then you set this enabled equals to true to that button. Connecting events we did. Window styles. So you can also change the style of the windows. So nowadays these are kind of a bit old Mac windows, so it's probably 10 years old. You can have the default style is something called Qt window, and it's what we had before. So let's go here. Window style. The default style is something called Qt window, and that is what we have seen before. This is the standard window. Looks like this, kind of boring. But it has also a maximize button, a restore button, and a close button. There's another window called dialog. And a dialog is a dialog box, and usually those windows are not resizable, so it's fixed. And it's also you can't maximize them. And you can also see here that I have only a close button here, and I also have a help button here, which is automatically added here. And you can see here that, okay, I can resize that as well. But usually you can also lock the sizing here. But I can't maximize it. And then finally, I can also do a special window called a tool window, which is a kind of toolbar that is floating on the screen. It has a smaller caption bar on top. So you can see here that it's a bit smaller on top here not to take out too much space, and has a smaller close button here. It's still resizable here. So this is the way you can control how the window appears. You can also, if you want to have an application that should be shown on the screen directly over the entire screen, you can use the set window state method to set window maximized. So that's here. So when I run this now, it will display the window on the entire screen. Okay. Try again. So it displays on the entire screen. You still have the window controls up here. You restore, minimize, and so on. Then there is a final window state, which is full screen. And that is usually done if you want to implement, for example, a kiosk, information kiosk, where you don't want the user to be able to access the other things on your screen. You can use full screen. Or you want to implement a game. You can go into full screen. The only thing that you have to think about is there is no close button on the window. So it will kind of, you need to know that you can close a window by using Alt F4 in Windows. So let's see what happens here. No controls, nothing, just white. The only way to exit is using Alt F4, which is there. It closes the window. So window state. Then another important part of a normal desktop application is menus and toolbars. So you can create menus in an application by using the menu bar class. And to that class you can add menus. And to the menus you can add actions. And the action is a combination of, so because you can have toolbars and menus, you don't want to repeat the code. There's a famous rule in programming called don't repeat yourself. So an action combines the action of a toolbar button, and a menu, and also a shortcut. So in action, you can tell if you want a keyboard shortcut for a certain action in your application, you can add that here as well. So menus are always connected to action objects. And as I said before, it's a generic connection in the user interface with menus and toolbars. And you connect events directly to the actions instead of the control. So for the push button, you connect the event to the push button. But for menus, you always connect the event methods to the actions. So here you can see here I have my application here. I create an action here, call it my action, connect it to self here, so it's owned by the main window. I can set a shortcut here, so Control T here, that is a shortcut, so keyboard. So when I press Control T, that will also trigger the action. And then you do action triggered, which is the signal it sends when you click the menu or the toolbar, connected to self on my action. So now I have an action, but I have no menu yet, so I need to connect these actions to the menu, and that I do with the add menu here. So the main window has a menu bar function that returns you the menu bar object of that main window, and I add that to this, add menu to this, and then I do file menu, add actions to this menu. So you can see here I have my action here. I add it to the menu. And here also, before we used the Q widgets as the base class, for main applications with menus and toolbars, you use the Q main window method here, class. So you derive, instead of from Q widget, you derive from Q main window. And Q main window has a menu bar, it can have toolbars, it can also have a status bar. So that class implements all the features you need for a desktop application. If I run this, you can see now here I have a menu. And I can click it down. You can see here it has a menu here you can select. And if I click that, you can see here that it shows the display here. But I can also press Control T on my keyboard. That also initiates the same thing. So you don't have to code keyboard shortcuts and menus differently. You can embed that into the action. Toolbars is very similar to menus. You have a same thing. It needs to be the main window class here. You add a toolbar, and then you add actions to the toolbar, and then you get. Now we don't have any images, but you can now also have images connected here. You will get this toolbar here underneath. My screen is a bit small to see here. You can see here that I have my file here, my action here. I have my action here on the toolbar. Works as well. And the nice thing here, the toolbar you can do all these things with it. That's built into the thing. You don't have to code anything of this. So in a bit bigger example here, I have a user interface for a file editor, for example. So I have excuse the Swedish here, but new öppna, save, avsluta, exit, cut, copy, paste, and I add all these here together. I create the menu, archive, which is file, edit, and I have all these things here. So I also add a toolbar here, and here you can also see that you can add icons here by specifying having a file in your directory here, call this, and it will load this icon and set that to the toolbar. So now we have a real toolbar here with actions and menus, and you can see here that different actions are called when I click here. and you can move it around and place it. Now I actually have two toolbars as well, so I can put them on different ways here and edit here. But you only have one action for a toolbar and menu, so you don't have to code duplicate triggers or signals here. You only have to connect everything to an action, and everything kind of stays together. So layout management. So we have placed the controls now by specifying coordinates X and Y, and this is something that could be problematic if you have a lot of controls. So for example, if you resize the window, what will happen to the controls? If you have X, Y, and absolute positioning, you have to move the controls if the window resizes. And that is something you don't want to do. So the solution to this in Qt is to use something called sizers. And sizers, they place controls automatically according to certain rules that you specify. So you can have a vertical sizer that sizes things in vertical order, and you can have sizes that sizes things in the horizontal order, and so on. And it's a bit complicated to get a grasp of to begin with, but it's really powerful concept. So the first one we'll look is something called a QV box layout. And that is basically a layout where you put all the controls in a bag and they will kind of be displayed vertically. So here I have 4 push buttons. I create a layout here. It's owned by the window itself. And then instead of adding the widgets to the window itself, I add them to this VBox. And then I set the layout of the widgets here to this VBox. And then the VBox will handle the positioning of these controls. So you can see here, we create the buttons. And we don't give any ownership here, so you see it's empty here. But when we add these widgets to the VBox, they are owned by the QV box layout. And then the main widget has a method here for setting the layout of this widget here to this layout here. So if you run this, you can see here that I have my buttons here. They are stacked on top of each other. And I didn't give any positions for this. So this is automatically handled when you add them to the VBox layout. Also, when you try to resize the window, it will position the buttons evenly spaced. And you can also see that it will stretch them out when you do it the other way around. It also has the limitations to how small the controls can be. So you can see it stops here when I try here. So it will also handle that. And you can also see that you can't make it smaller than a certain size. Then, of course, you can have a horizontal box layout as well. Put the buttons in the other direction. Works the same way, but it's called H-box layout instead. Create the controls, add them to the widget, and then we run. Now you see I have the buttons the other way around, and now you can see they stretch in other direction instead. And you can see here there is a stop here because the the buttons have a minimum size that they have to be, and also a minimum size here. Then you can combine these, of course. So and here is where you have to think a bit when it's a good idea when you design your user interface that you actually do it on pen and paper first. Sketch how you think your user interface will look, and then adapt to the different sizes here. So in this case here, I have 2 sizers. I have an outer sizer here called the VBox, and I have an inner one here that is called HBox. So first I add the VBox, and then I add button 1, 2 to 4 in this box, and then I add the HBox to the VBox. So this will come to control inside a vertical sizer here. And then you can also add springs to the design. If you don't want them to be evenly spaced, you can put a spring here that pushes the buttons up. So running this, you can see add stretch here. That acts as a spring and pushes the controls up. So you can see here I have 4 buttons here, and then I have a horizontal layout here. And if I resize here, you can see here that the stretch here forces these buttons up here, and you can have a stretch here as well that forces the buttons on the to the right side. So it could be that you have help button here and OK and cancel here. And if I remove these and just comment them out, looks kind of the same, but if I stretch it now, you see here that they are evenly spaced, which looks kind of odd. And there is also something called a grid layout, which is where you place the controls according to rows and columns, and not according to pixel, but more. I want an application with 3 rows and 3 columns, and then I want to place the button 1 in column 0, 0, and so on. And they are placed and resized according to that basic layout. And I think I will do the grid layout. So the first thing, we add a lot of buttons here, and then we want the buttons to be able to expand. So there you can set some policies here how the buttons will behave. And then we add the buttons here to the grid layout here by using the rows and columns here. So 0, 0, 1, 0, and so on. And then you can set how much margin there should be between the different columns. And you can also set the horizontal spacing between the controls. And then you can add stretch between different parts of the layout. So if we run this again, I have like a calculator here. If I stretch here, you can see here that these buttons here stretch out and other ones don't. So in this way you can have a layout that has, for example, toolbars on the right side and left side, and then you can have a main window here in between here. So it's a quite flexible main layout. And then you can have internal layouts in the different parts of this window as well. Let's see if I can do. So standard dialogues. So you probably have encountered these on your application, on your machine. So when you do something that initiate an error message, you usually can get a pop-up box on your window, on your desktop. These are called message dialogues. When you open a file, you usually use something called a file dialog. When you select a color, you use a color dialog. And you don't have to code these yourself. So these are built into the operating system. They're built into Qt as well. So instead of coding your own window with a message box or message display, you can just call a function to bring up a standard dialog. The easiest one to use is the Q message box information. Here is the information here, that is the function called. Self is the owner of the dialog box, in this case the main window, for example. The message, no sorry, the title bar and the message. So you can see here I have my menu here, and I call this dialog box here to show the window. I'll show the message box. I actually already showed this to you before. So this is the message box here. And in this case, I can only press OK. I can also do, if something is really critical, there's something really wrong with your computer, you can use the critical function as well. And that will bring up a different dialog box, which doesn't look as nice. It's ouch. And then you have the middle ground, which is the warning. And you should be sparingly use the warning and the critical, because they kind of trigger stress in the user. So if it's something that is not kind of super important, use the information function still. It's kind of nicer. And you should also be aware when you call these functions, the user interface blocks. So you can see here I can't access my window anymore. So it's a blocking user interface. So sometimes many users can think that this is really annoying, because you can't do anything until you click the button here. Sometimes you want that, but otherwise, if you can find another method, it's probably better to do it with non-blocking means. So I think we have a 15-minute break, and then I will continue with the other dialogues. Yeah. Okay, so we did dialogues. We are going to do short what other dialogues there are as well. So in addition to the message dialogues, we also have a dialogue that you can use to ask a question, for example. So the function is called QMessageBox_question, and then you can put what options you want, so yes or no, and what the default should be, and then you can query the result here. If the result is message box yes, then I chose a certain thing. So it looks like this. I have here the message box function here, and then I have an if statement here just checking what the result were. So if I run this, you can see here that I have a message box here, ta bort or erase. The default button is no, which could be good if you have a critical option that give the user the default to not do it. So if I press enter here, use the keyboard, it will select no. You can see here, I pressed yes. If I do it again, I press no. Press no. Another one that is you will use in this course is the file dialog. There are two of those. There are one file dialog for opening files and one file dialog for saving files. So they're a bit different. The one open, you select an existing file, and the other one, you create a new file name at a certain location. So you have get open file name here, owner, what the caption of the dialog should be. And you can also give a default file name here, and you can give a filter here which files to show. So if you give a star INP, it will only display files with the extension INP. So file, open dialog. And so for Windows here, you can see you get the standard Windows dialog box for selecting files. And now you can see here, I don't have any files to select because the filter here is INP. I can actually give a filter here just to show you how it works by star here. And now you can see all the files in my directory here. So if I select a file here and press open, you can see here it displays the complete search path for the file I selected here. If you don't select anything, press cancel, the string return will be empty. So you can check, the user can check here if file name equals to empty, not empty, then it will display, otherwise it does something else. And also it has a second parameter here which we ignore by putting the underscore there. The other dialog is the get save file name, and it's the opposite. But here you have to enter a new file name. And on a Mac, you will get this first item here where you give a file, and it's kind of a compressed version. So it will display the system dialog boxes for the different platforms. So here you can see we have get save file name. And I get this standard Windows for saving files, and here you can enter a file name. So my nice file. And also you can see here I have a filter here as well. And the nice thing with this is that if you don't give an extension, the selected file will be, the extension will be added to that one. So if I press save here, you can see here that it creates a file name here with the extension added to it. And this file doesn't exist yet, so it's your responsibility to create the file. So the save file dialog actually only selects a potential file name. So, next part. So we have already seen some controls like the push button and so on, but there are many, many more controls that we can use to kind of build our puzzle of user interface, build our user interface with. And that is also the mean we interact with the user in some ways. So I will just go through them quickly here. So we have the checkbox, and that is a button with a state. So when you click a checkbox, it will indicate that it has been checked. The radio button is a checkbox which works in a group of controls. So a radio button can only one of the radio buttons in a group can be selected at one time. So a Q radio button always needs to be contained in a group. Otherwise, all the radio buttons on a window will be, only one of them can be checked. The checkbox can be checked, or the state of a checkbox can be queried using or set with the check state and the set check state and check state methods. The radio button is set checked is checked. So the code here is, you create them just like a button here. So checkbox, the text that you should display, and the owner here. You can move it. You can set checked here that it should be by default checked. You can also connect state changed signal here to a method here. So you can query if the control has been clicked or not. In many cases, you don't have to connect events to these controls because you can query the value of them afterwards, for example. So if you press OK on a dialog, you can afterwards query the controls and you don't really have to have the check state here. So here you can see I have it's pre-selected here, and now it's not selected. Now it's selected. The radio button is the same thing. Let's go to radio button. So we create here 2 radio buttons. We connect them as well. And you can see you can use the same methods on this one here as well. But you can see here that you have one here is selected, the other one is not. And if you select this one here, you can see that the checkbox from this one was removed. So only one of a radio button can be selected at one time. So you can give the user a set of selections that only one of them can be selected. Combo box, it's a multiple selection control. So you can have a list of options that the user can select, and when you click that, it will drop down a list to select. So it's a compact control. When you have not so much space, you can use this to kind of create compact user interfaces. And you can query which selection it is using the current index method. So here you can see I create a combo box. I add some items to it here using the add item method. And you can set the which item should be pre-selected using set current index. I can connect the signal current index changed to my own method here. So every time a new selection is done, it will call this method here. And then you can query current text here, and you can also query the current index here. So this slot here requires you to have an index method here on the call here as well. So let's see what happens here. So now you see here that this is the combo box here. If I press it here, you can see it drops down And you can see I have one of them pre-selected. And you see, and you can also get the text here that is part of this. So it's a quite compact control, but you can give a lot of information to the user here. Slider is another control that enables you to input quick numerical values. So you can set a min and max value on a control, and you can have a slider which you can move by using the mouse. So here's an example here. I have two sliders, one vertical and one horizontal. And you can see here you can have slider, and then the first parameter here if it should be vertical or which should be horizontal. You can set the max value, the minimum value, and the current value here using these methods here. So slider 1, slider 2, and then you can see here that I have connected value changed here. So every time the slider changes its value, it will call this, initiate this signal, and you'll be connected to our value change method here. And we just print out the values for the different sliders. A bit hard to see here, but if I do, you can see here that if I drag this slider, this event will trigger. Same thing if I go up and down here. So for example, for mesh generation, you can have a slider for a fine mesh or coarse mesh, and the user can slide between the fineness of the mesh. List box is very similar to the combo box, but it will display all items in a box until they are not visible, and then you can have a scroll bars on the side to display, to move up and down in the list. It also supports selection of multiple items in the list, if you want that. So here you have a list box just like normally. You can have set to add items here. So now I add actually 100 items to the list box. And I set the current item to current row to 2, which is the same with the combo box. You have the current row changed, same with as the combo box. And then we can see here what we selected here. So now you can see I have 100 items here. So a list box is nice if you have a lot of values that the user selects from. I mean, the combo box has the limitation of it can't drop down more than the screen, and then you have to have scroll bars in the combo box, which is not always a good idea. And if I click here, you see that it gets the values that is here. This is also the reason that this message box can be quite annoying, because you need to press OK. Line edit. This is probably one of the controls you will use most in this course. And it's a control that displays a single line of text where the user can enter text, values, numbers, and anything. It stores not numbers, but text. So if you want the user to enter numbers, you need to convert to and from strings, getting back floating point values. So you can see here that I create a line edit control here. I set the text to text, and then then when I click the button here, I will display the text in the text box. So I have a text control here, button click there. So you can see here I have a text here. I can enter any text here. And if I press here, you can see I get a text from this control. And you can have edit. You can contain anything here. So I've gone through the basic controls. Now I will kind of discuss how you think on when you're designing a user interface, how to separate the user interface from the model itself. Because when you design your user interface, it's tempting to kind of build everything in a single module, but it's often a very good idea. For example, the computational model, it doesn't have to know anything about the user interface. The user interface needs to know everything about the computational model, but not the other way around. And it's also sometimes it could be that the user interface shouldn't be Qt at some point, it should be a web interface. Then you want to be able to remove the Qt code and add a web interface to it, but you don't want to change the basic model that you have implemented. Your computational model should stay the same. So I will just illustrate with a simple example here how that can be done. So interface not to mix user interface code with simulation models. And also somehow handle the update of the user interface in the model in a consistent way. And so what I usually do is I separate functions for setting the controls from functions that get values from the controls to the model. So usually have update controls that takes the values of the model and puts them in the controls. Update model queries the values from the controls, assigns them to the model. And then you can also reuse this function whenever you need to kind of get new values from the controls. You can call them again in different parts of the model. So I will do a simple model here. I have a model here containing different values here, different types. I have also a print routine here to print out the values. Then I design a user interface for that with the different options. And then I have update controls that will take the values of my model here and assign them to the controls. And you can see if I have a flag here, I need to kind of query the flag. If it's 1, I should check alt radio 1, set check true. If the flag is 2, I should set check, and so on. And then if the user changes the controls, you need to assign the value back to the model again. So querying the controls and assigning the values back. And here you need to convert from string representations to floating points. So for the text values, there's no problem. You just assign the text, there is no conversion. But for the value 1 here, we need to use float and then the value here. And here you also have to check if this option, if it's a Boolean value, you have to use the is checked here to return true or false depending on the value. Some controls have a value that you can use directly and so on. So you need to kind of take care of going back and forth. And then you also need to do error handling as well, because the floating point conversion here could generate an exception and crash the program. So I will do a simple example here. The smallest model I found here was a simply supported beam, or how to carry a load. So we will implement a model that implements simply supported beam. Very simple computational model. I have a force P. I have the values A and B that defines the position of the load, and I have some functions here to compute the deflections and section forces. So the idea is that we create an object that is our beam. So I have a class here called beam simply supported. Very creative name. And then I set the values here, A, B, P, E, I, to this beam model. And then I can do stuff like this. I can just loop over here and plot the different values here. One easy way to do it. Then I want to create a user interface for this. Yeah, and first I just show how it can be implemented here. So here I have init here. I assign the standard values here. In this case, I have used private values here, so those you don't have to do it. You can also use self.a here if you want. And then I also added a way of automatically converting to float with a fallback. So for example, here I have two float method here. So it takes a new value, so the value you want to assign, and the old value of the existing value of the model. And then you do try here, and you try to convert it. If you fail to convert it, it just returns the old value. So in that way, regardless of the user entered text in the control box, you will, worst case, get the old value back. And then I have used something called properties here to handle this here. So for example, I have A here, return self to float V self A. So it refers to its own attribute here, and it doesn't assign it until it's correct. And then I have implemented the functions here for calculating the section forces. And here you can also see what you have done already in your worksheets here, that you do shortcuts so you don't have to type a lot of code here. Calculate the moments. Yeah, so that is our model. You can do it very much simply. You don't have to use properties, but you have a model that can do these things. Then we want to have a user interface. We want the user to be able to enter A, B, P, E, and I. So now we create a beam window. We import our beam model into our user interface here. So beam model is the classes we defined, the simply supported beam, import as BM. We create our beam window. We give it self beam equals to beam simply supported. So now we have a reference to our computational model. The computation model doesn't have to know about this window. It just exists here. We update the controls. We update the text edit. And here you can see we create our user interface here. Create the labels, the line edits. And then we also connect on edit finished. So there is a method called signal calls editing finished on a line edit, which is called when the user has completed entering text in the line edit. And then we do update controls. It just does set text string self beam A. And then update text edit here. This will loop over and create the list of the moments and shear forces. And then update model. If the user entered things, we just assign the controls here. And here we had automatic conversion here using the toFloat method here as well. So it automatically assigns and converts. And if the text is wrong, it will not work. And then we can reuse here on editing efficiency. We update the model because the user has changed the controls. We update the text edit, and then we update controls again, because if something was converted wrong, we need to update the controls again. So let's see here if I have this. So here I have the B model with my internal attributes. I have my properties defined here with the set to floats here. And if I run this standalone, I will just get output here in my bottom part here with the deflection, shear forces, and moments. Then the beam UI looks like this. I create my user interface here, and here you see I also create the layout here, grid layout, and I add the labels and the line edit to the right of that. And then I do the text edit control, and I connect my events here for the editing. And running this will look something like this. So if I enter A here, you can see here that it goes back to 2 again. It's only when I do 2.2 here, it accepts the value. And you can see also it automatically calculates here the forces. So if I do 2 here, you see the table will update automatically. So I can't actually make it to crash, because if I try to enter something here, it will go back to the normal again. So that is something you have to think about when you code. Try to code defensively. The user will make errors, And it's very important that you handle those errors as well. So, finally, I will present you something that will make your life designing user interface much easier. So now I showed you how the hard way to code user interfaces, creating controls by yourself, adding them to the form, and now I will show you the designer tool instead. So designer is started by, if you go to Anaconda prompt and type designer, you will get like this. It will open the application. I already have it running here, so it looks like this. So here you can do file, new, and you can design a standard widget here like this. Great. It will create you a window here. You can resize this. On the left side here, you have all the controls. You have the layout managers. You have the spacers here, the stretch variables. On the right side here, you have the object hierarchy. So here in this case, we have a form QWidget. We have properties here. So the properties for the currently selected object, in this case is the form. So you can see here that you have fonts, you can have, there's also window title here. So if I do my window here, it will show up here automatically. And with this here, you can save these. So if you can do a push button here, you can see here that you get a push button here, and it's named push button. You can name it something else. The first property you have is the name, and that is the name that will appear in your Python code. So it's important that you name it something reasonable. So, for example, execute button, for example. I usually have called them the name of the function here, and then the button here, or what I should do correctly here, should do execute button, like that. And then I can use that from Python later on. Now you can see that it's the class here, and you can see you can go down and set the. So if you go down here, the first parts are the generic things that are common to the widget properties here, and then on the below here you get things that are related to the button here, and you can change the text here, execute, like that. So what is this useful for? Yeah, so large user interface are complex. You will perhaps have hundreds of controls, hundreds of different things, many windows, and that is really hard implementing that in code. I mean, it takes some time to do it, and also to be able to test different user interfaces with a user, it's important that you can be flexible and move things around, and then it's important to have a tool. So the Qt supports a special XML format which describes the user interface. They are called UI files. So you define a user interface, you save it into a UI file, and that UI file can be loaded by Python or Qt and recreate your objects for you automatically. So it's very effective. So in your code, you have to, now I'm not sure this bit's wrong here, but there is something called UIC, and UIC load UI. Then you give the file name of your user interface file, and the important thing that you put self here. Then load UI will load all these objects and assign them to your main window as if they were created by you in that main window. And then the push button here will be the name of the object here. So let's see here if I can do form UI. So here you can see I have that was not one. This one. So Qt import UIC, I have a form here. I will create a new form here. So here I will do save this file here. I will call it execute button here. I've done this a separate couple of times. And then I call it execute button. And now I can set properties of those by myself here. So if I run this now, you can see here this button was created by loading the UI. Now you can see you can connect it, but I didn't have to create it, it was just there. And I also wanted to show you a bit more complicated way of doing it. So let's see if I go back here. So for example, if I want to create a user interface with an editor here in the middle, what I usually do is that I just roughly put the controls where I want them. So let's see here if I have a text edit. I name it text editor, like that. And then I want to have buttons on the left side and the right side. So I do just put some buttons here. Don't have to be too concise here, just put them out. And then I have some buttons here on the bottom here. Then we have some buttons on the right side. Like that. So now I have all roughly the user interface here. I want to have the left buttons here should be vertical spaced. Same thing with the right side here. Then I have a horizontal spacer here with this group, and this group. And then I have two columns here that will contain these ones as well. So I start with a smaller one. So I start with just grouping these together here, just selecting it like this. We press this one here, layout vertically. Zap. Same thing here. I group them together. I do like this. Then I want to group together these ones here as well. No, I forgot that one. Like that. So, and now I want to create the global order here. So I want to create, these ones should go together in horizontal spacing. So I can group them together and do like this. And then the outer layer ordering would be two rows like this. And then I can click the outer one here and say that they should be layout vertically like that. But that looks really bad. I want the buttons to be on the top. Then I use a spring, a vertical spacer here, and just put it in here. And it pushes the controls together like a spring. And then same thing on the other side here. And then here the same thing. I want the left button here and the rest one should be pushed together here. I can do horizontal spacer like this. And then I want some default text here as well. So let's see here if I can enter some text. Like that. Save it again. I will rename that to push button here again. So now you can see here, I didn't code single line for this user interface. I loaded from UI file, and you can see also I could access the controls here by variables here in Python, and it's nicely scrolls like this here. I can also add, so now I changed that to, we'll create a new file here, a new main window here instead. So a bit tight here, let's squeeze it together. So now instead of having a Q widget, I created a main window, and now I can also create menus here. And it's really easy. If I want to create a menu, I just press enter here, press file, and I can do press file here, open, save. I can add a separator here, and I can do exit like this. And now I have a menu as well. And also there is a status bar here on the below here. So let's see if I can save that as 110. And now I need to actually queue main window. So now you can see I have a main window here as well. So when you implement your user interface, you should create a new user interface based on main window, because you need to have a menu in your application. And it works like this. So in this way, you can save a lot of time. You can see the code is quite compact. It's only one line to load the UI file. If you look at the UI file, you can see it looks like this. So this is the XML file describing the user interface. And that code you have to enter in Python otherwise. So it saves you a lot of time. And it's also very quick to, if you want to change the user interface, you can do that in a single file. You don't have to change your code, except if you change the names in your file. So that was the Qt Designer. It's quite powerful. It's also built into, if you can't find it somewhere else in your, it's also available in Qt Creator. You can use Qt Creator to create UI files as well. So let's see if I have something else here. Yeah, I have one more. I will show you a bit bigger application as well. I think I have time, yes. If you have read my book, Infogeneral's Guide to Python, there is a beam application as well that calculates a continuous beam. And this is a complete application here. It contains the beam model. And I will show you how it's implemented here. So you can see here I have in the beam model Python file, I have a beam model class. And it contains some constants here for defining if it was a support type. When you create a new, it creates length here. So this is a 3 support beam. You give the length here, the number of segments of each beam, the loads of each beam, the supports, and some properties here. So here, everything is contained in this model. I have a method on this and in this model called solve. So in this case, I have decided to combine the input model with the solver because it doesn't need that flexibility in this case. And it uses call from here to assemble together and assign the results to the output here. So this model doesn't have any connection to the user interface. It has the save JSON here, so it does the same thing as you will do here to save your model to disk, and you can load it again as a JSON file. And here's an example how we can use it here. So you can create a beam, you can give it the length, the segments, the supports, the loads, and then you can solve it. So if you run this one here, okay, it's I think it should be. I haven't tried this for a long time here. Okay, I didn't print out anything here. Okay, yeah, so this is the base of the model. Then I have a beam app, and that is the beam window, the Harrison Cube main window. It loads the user interface here. It creates a new model here, which is the beam model here. So here you can see I create a new model here. And there is a menu here for on new, exit, open, save. So here you can see you can use the open and get save and fail line to read, and then I called the save JSON here and I open from JSON here. And here is the main application here. So I create the application, I create the beam window, and I show. So let's see how it looks. Okay, some things here are not working today. Then I also have the thing I also have here is that I have a model. I also have a special window type called beam view that displays the actual application or the beam. So it loads the model here. It comes from the constructor here, and it uses that to visualize the model here. But I'll see if I can find where it's wrong. 39. I need to check what's wrong with this, but I will make sure that you get one that works. It's also available in that zip file that you have. So it's here. Okay. So this is the application, and this part here is the beam view. So that displays the beam model. So I think the support here is wrong. So that should be a triangle here, and that is the thing that doesn't work. Then it just displays the loads, fixed support, and then you have windows for defining the beams. So if I add, for example, this one to 3, I can update and it will automatically recalculate here. You have supports here to change here you can see the radio buttons, and here is a list box for selecting the different supports. And then you have save, and then you can see you get a dialog box like this. You can create a new model, and here you have menus here for the same functions as we have here. So this is a matplot window here that displays the model and the results here. and the beam model itself doesn't know anything about this view here. So I have a view that looks at the model, and the model just needs to provide information here in the plot here. So this is a bit bigger application, and you can look at this. I mean, it is very similar to your application, and you can get some ideas on how to implement your application with this. So that's a free tip. Okay, I don't have so much more. Any questions?